Let's talk about metamorphic rock formation. This is going to assume that you have some base knowledge in non-foliated versus foliated rocks, and also some common foliated, non-foliated rocks, but we'll do a really quick review. So remember that we can take a limestone and turn it into a marble. So this is sedimentary limestone that gets metamorphosed into marble. We can also do sandstone into quartzite. I'm going to kind of ignore that one for today. And then we can take a shale, and our shale is a sedimentary rock, and it can turn into a slate, phyllite, schist, gneiss, or a hornfels. And so the one thing to remember is with this top sequence, this line is here for a reason, which I'll talk about. If you apply a little bit of pressure and temperature to a shale, it'll turn into slate. A little bit more, it'll turn into phyllite, a little bit more, schist, and then finally lots of high temperature pressure, and we get a gneiss. So hopefully you have that background information. If not, read up on how those form and then come back to here. So I'm going to talk about how we form each of these at a ocean to continent convergent plate boundary. So we have our oceanic crust that's diving down underneath our continental crust. A melt is generated, so you see that magma there. That could eventually cool to form something like a granite or a gabbro. And that melt will continue up and form our volcano. That could be a rhyolite or an andesite, something like that. So we're going to kind of ignore the igneous rocks for now, and let's talk about what happens around these areas. So I'm going to start with limestone, and I'm going to assume that, so I've got it here in green. I'm going to assume that there was limestone over here. It extended off to the right, but I'm just kind of simplifying it. So there was limestone over here in this continental crust, and there's also a little band of limestone. And this is just for demonstration purposes. I've got these kind of in discrete areas, but of course they would extend out further than that. Okay, so you're actually going to form marble in both of these settings. And so that's just because you've applied pressure and temperature, and we know that limestone converts to marble. So here we have marble that forms, and here we have marble that forms. So pretty straightforward, nothing too crazy there. Where it gets interesting is when you have shale. And so I'm going to tell you that we've got shale in two spots. So I've got it in blue and red there. So the area around the magma body to the left here is shale, and so is this blue band right here. But two different things are going to happen there. So over here, where we've got a lot of directed pressure, so we've got this convergent boundary, everything is squeezing together, that shale is going to turn into foliated rocks, because remember, foliated rocks are going to have that orientation. And our foliated rocks, if you remember, are these top ones here. So here's my foliated rocks. Okay, so because we're going to get that orientation and that directed pressure, here we're going to get, depending on at low pressure and maybe low temperature, your slate is going to develop here. And as you increase down deeper, you're going to get higher temperature, higher pressure. You're going to get a phyllite here. Even higher temperature pressure, you're going to develop a schist. And then even higher temperature pressure, you're going to get a gneiss here. Okay? I've kind of got them spread out just because we can see it easier, but eventually you get down to some melting and things if you've got too high of temperature and pressure. Okay, so those are our foliated rocks. Now, if we take that same shale, we're over here next to the magma body. Now, it's going to have high temperature because of the magma body, but it might not have that same pressure that it gets at this collision zone. And so because it's not getting that squeezing, it isn't going to produce a foliated rock. It's going to produce a non-foliated rock. So non-foliated, which is my hornfels. And so right in here, I would get the non-foliated hornfels. So that's the big difference. Depending on whether you're getting that really squeezing pressure or just kind of an overall general pressure from depth, you'll produce two different rocks, the hornfels or the slate to gneiss series. Now, I wanted to go back to one more thing. We talked about limestone, and you might be thinking, well, why doesn't limestone form a different rock when it's over here and getting really squeezed? And that's because limestone, and the same thing would be true of our sandstone that turns into quartzite, These two rocks are made of, limestone's made of calcite, sandstone, it would be a quartz sandstone. Those minerals, calcite and quartz, they don't get an orientation. They don't get a flattening to them like the minerals that make up these rocks do. And so even if you really squeeze them in one direction, they're still going to produce grains that are kind of what we call equant, so kind of equal in all directions, equant in shape. And so you aren't going to get some different rock. You're just going to get a marble that looks just like the marble that's over here. So hopefully that helps you to understand how we take our foliated, non-foliated rocks and our limestone and sandstone and how we convert those and how we can get different rocks, or sometimes the marble, the same rock in two different settings.